Alright, hello guys, welcome to another random coder video. Today we'll be solving Leetcode question 238, product of array except self. So the description reads, given an array nums of n integers where n is greater than 1, return an array output such that output position at I is equal to the product of all elements of nums except nums at I. So what this wants you to do is for each one of these numbers, you want to find the product of everything else. So say at 1, you want to find 2 times 3 times 4. At 2, you want to find 1 times 3 times 4. At 3, you want to find 1 times 2 times 4, and then etc. And then it'll get you this array. So the constraint reads that it's guaranteed that the product of the element of any prefix or suffix of the array fits in a 32-bit integer. And then it wants you to do this without division and in linear time. So this is actually a dynamic programming problem, and a prefix sum sort of array, but for multiplying would work in this situation. What I mean is, so you have the array 1, 2, 3, and 4, right? So to make prefix sums easier, you usually what you do is you make another array that's this array size plus 1, so this will be size 4, so this will be actually be size 5, and this as well. So there's another prefix sum multiplier array because you want to have one going from left to right and one from right to left. So what you want to do here is you want to make the starting value of 1 to make things easier, and then so basically this multiplies by this, which results in 1 again. And then this one multiplies by the 2, so that's a 2. And then this 2 multiplies by 3, which gets you 6. And then 6 by the 4, which is 24. So you can see how we kept multiplying consecutively to reach this value. And then for this array, you actually want to start from the opposite side. So opposite side would start as a 1. And then you multiply this 1 by the 4, so you get 4, and then you multiply this 4 by the 3, which gets you 12, and then you multiply the 12 to the 2, and that gets you 24. Sorry, my bad. 24. And then you multiply 24 to 1, which gets you 24 again. So basically this is the array that we're going to be looking for. And after this, it's going to be pretty easy to get the answer. So if we want to find the product except for 2, all that we need to do is actually get the index before this. So this one, so at this, so this index, so 1. And then you actually just multiply it by the index plus 1 in the second array, so 1 times 12. So it should get you 12 for 2, as well as all the other numbers, which should get you this array. Alright, so let's start coding this. So I'm gonna name my two arrays dp1 and then, sorry, dp1 and dp2. Because this problem's dynamic programming problem. So now that we have our arrays, we want to set the first and the last of the array to be 1, so we don't have any zeros in our products. So dp1 at 0 should be 1, then dp2 at dp2.length minus 1 should be 1 as well. Now we can start adding values into our array. So int I equals 0, int I less than nums.length, because we don't want index out of bounds, and then I plus plus. And to make things easier, I'm actually gonna get another pointer called j and set that to dp.length minus 1, because I'll be subtracting j as we loop. Alright, so basically what happens now is we want dp1 at the position I plus 1 to be equal to dp at the previous position, which is just I itself, multiplied by nums at I. Alright, this is actually pretty straightforward so far. But once we get to DP2, what we want to do is we want to have j minus 1 because this is actually just the last value. So we want j minus 1 equal to dp at j multiplied by nums at j minus 1. And this is because nums is 1 shorter than dp2. So if you want to get the last value of nums, or to be more straightforward, if you don't want to get an index out of bounds, you have to subtract 1. So now we have finished putting values into our arrays, and we can actually do the um, last part of this problem. So our last part, we're gonna have to use another for loop to put values into the end result array. So we're just gonna modify this this nums array itself to make our memory usage better. So we want I'm less than nums.length and then I plus plus. So there's actually a few cases here that we need to process. The first case is when I is at 0, and then the other case is when I is at length minus 1. So what this means is when it's at 0, we need to find these three. So what we need to do is use the second DP array. So what we do is at 1, we just add 1. Add 1 to the index, which gets it 0, 1, so this one. So this would be the product of that. When we're at 4, or when I is equal to 3 in this case, we actually use this array, and we take the 3 in here, so 0, 1, 2, 3, so it's that number. So that number corresponds to here, and that's our two cases that we need to process. So in the code, what we can write is if I is equal to 0, then nums at I could be equal to dp2 at I plus 1. Or else if I is actually at the end of the array, which is nums.length minus 1, we want nums I to be dp1 and then I, just I, because dp2 is flipped. So now what we can do is actually just have our last case, which is an else. So this case is fairly straightforward. We just take the two sides, so dp1 at I multiplied by dp2 at I plus 1. And then once we finish this, we can just return nums. And it looks like we actually got a runtime error. Let's see. Oh, we got a compile error. I accidentally forgot to name these by accident. Sorry, guys. Alright, this should be good now. Yeah, so it outputs the right answer, and these are the right answer. Let's try another test case. So let's add a 5. Alright, that looks good as well. So one of the corner cases of this question is probably 0, because that's the trickiest test case. So we want to test 1 0 and 2 0. So that looks good, and then let's just put another 0 in our test case. Alright, that looks good as well. Let's submit this problem. And we passed. Alright, let's talk about the time complexity of this problem. Because we're actually using a prefix sum multiplier array, so we got for loop, so that's actually linear time. So we accomplished this, and then we also did this without division. Alright, that's it for today, guys. Thanks for watching, and remember to like and subscribe the video.